we've talked about how to summarize symmetric distributions. Now we want to look at what's the right tools to describe center and spread in skewed distributions. Let's start with the center. When you have a skewed distribution, rather than use the mean, we're going to use the median. The median is literally the middle point of the distribution when the elements in the distribution have been ordered from smallest to largest. If n is odd, where n is the number of observations, then your median really is exactly that middle observation. So here's our example with the class grades, and I've listed those grades in order from smallest to largest. The median here is highlighted in red. It's literally the middle number. You can see there are 4 numbers to the right of the median and 4 numbers to the left. Here the median is 77. What if you have an even number of observations? Well, then the middle actually has 2 observations, and so to get the median, we're going to take those 2 observations and find their average. So here class B had 10 students, and so there are 2 values here in the middle, 83 and 84. And so I'm going to add those together and divide by 2 to get a median of 83.5. When do we want to use the mean to describe the typical value versus the median? Well, let's look at this histogram of income for New York residents. Which measure looks like a better measure of the typical value? On the left, we've got our mean illustrated with the red triangle, and on the right, we have the median drawn as a red line. Well, here, the mean, you notice, is pulled to the right of the skew. And so that mean probably is too big to describe the typical income of a New York City resident, because so many of the residents are down here in these large bars on the left of your histogram. So when you have skewed distributions, the median is a better measure of the typical value. What about measuring spread? We can use the range as a first description of spread in a distribution. The range is just the difference between the largest and smallest values. The scores on an exam in a class of 9 students were as follows. Let's find the range of scores here. Well, I've already got these in order, so the range is going to be the difference of 98 minus 56, or 42. So these scores range over 42 possible values from 56 to 98. Notice that if there's an outlier, that can greatly affect the range because your outlier is going to be most likely your smallest value or your largest value. We can also use the interquartile range, or IQR, to describe the spread. So the interquartile range is going to give us the middle 50% of our data. To do that, what we're going to do is cut the data into quarters, or sections of 25% of the data, using something called the quartiles. So to do that, we're going to first arrange our observations in increasing order and find our median. Remember, that's the value in the middle. Then we're going to take those 2 halves on either side of the median and find the median of each of those halves. The lower quartile, or the first quartile, is the median of the lower half, the observations to the left of the median, while the third quartile is the median of the observations to the right of the median. The interquartile range is the difference, Q3 minus Q1. So let's look at an example here. Here's our class A again. Remember, we found the median was 77. So what we want to think about doing is cutting through that median. We're going to ignore that 77. So I have 4 numbers here on the left of the median. And so if I wanted to find the center of those 4 numbers, or the median here, it's going to be here in the middle of these 2 numbers, 70 and 72. So I'm going to add 70 plus 72 and divide by 2. That gives me 71. So my first quartile is 71. Now to find the third quartile, I'm going to look at the upper half and find the median there. So the median here is going to be the average of 87 and 95. And that's 91. Now I just wrote over my screen. The interquartile range, let me erase so you can see. The interquartile range is the difference Q3 minus Q1. In this case, that's 91 minus 71, which gives us 20. Let's find the interquartile range for Class B. Now, Class B, remember, our median was found by finding the average of these 2 middle numbers. So our median here was 83.5. And so when I cut my data in half through the median, these 2 numbers are going to survive. So 83 is part of this lower half, and 84 is part of this upper half. All right. Now, I have 5 numbers to the left of the median. So the middle of those 5 numbers is 75. This is going to be my Q1. And I have 5 numbers to the right of the median. The middle here is 86. This is Q3. The interquartile range is Q3 minus Q1, or 86 minus 75, which gives me 11. Let's look at another example. Here's a dot plot with the distribution of weights for a class of introductory stats students. The vertical lines slice the distribution into 4 parts, so each part has about 25% of the observations. The middle 50% of the data values are between 121 and 160. So this red line represents our median. Our quartiles, Q1, Q3, along with the median, cut the data into quarters or chunks containing 25% of the data. This one actually goes out to here. Okay, so 25% of the weights are between, say, 100 and 121. Another 25% between 121 and the median, and so on. The interquartile range here is 160 minus 121, which is 39 pounds. Okay, so the middle 50% of the data values are in that range of 39 pounds.